Okay. All right. So let's start with the first one here. And so as we look at these, the sympathetic nervous system versus the parasympathetic nervous system, we this is just kind of some places you can plug in whether it's sympathetic or parasympathetic right here. And then what are kind of the implications of this? So kind of just talk through this for a sec, and then we'll come back together in a minute. Okay. You don't need to hold anything up or put anything on your clickers. This is just one to discuss. You're filling this out. All right, let's go ahead and just chat through this one here. And yeah, so when it comes to lots of neuron branching, which one do you guys think for that? Sympathetic or parasympathetic? Sympathetic, you got it. And what that does is it makes it so the effects of the sympathetic nervous system are broad, meaning that we're not specifically just changing one thing with the sympathetic nervous system. We're kind of having broad effects on the whole body when we have a fight or flight response. Okay. Second one, short postganglionic neuron. So this is meaning that there was always a 2-neuron chain in the autonomic nervous system. And the first one is a preganglionic neuron. It goes from the spinal cord to the ganglion, which is just collection of where two neurons talk to each other and communicate with each other. That first one's really long, and that second one is super short. That's always the case in the parasympathetic nervous system. A lot of times that second one is super short, and it's just embedded in the same tissue that it's innervating. And so this one is kind of causing really exact slash specific effects. Kind of just going to one exact tissue directly, and we're affecting that one only. So exact effects, specific effects is there. Okay, the one that uses hormones that are released from the adrenal gland, which one is that? That's sympathetic, right? This is our adrenaline, right? But epinephrine and norepinephrine is what they're called. And so this would be long-lasting effects. And again, very widespread or broad effects. Because we have to wait for the hormone to get broken down, right? The hormone has a half-life, so we can't just turn it off. But as long as it's out there, it's still affecting our body. And secondly, just anything that has a receptor for it in our whole body is affected by this, right? It doesn't have to be directly by the neuron. And then this long postganglionic neuron, again, is sympathetic. And this kind of connects to this one up here again. It gives it a lot of ability to branch, right? The longer that is, the more it can kind of branch and connect to other things. So it's really connected to that same thing of having just really broad diffuse effects in the sympathetic nervous system. Okay, questions on those at all? Okay, so this next one will be one that you can talk through with your team. That's supposed to happen when the timer's up. I don't know why when I use it on the iPad, it does it before, but yeah, so go ahead, talk through this one on your team. Have one person on your team hold up their finger with just one for A or two for B when you're ready. You don't have to wait till the timer's over. Just go for it. All right. All right. Everybody, every team's got to vote. Okay, thank you. Yeah, so everybody's saying B, sympathetic nervous system. Uh, this makes animals look bigger, right? That's the big thing. Most animals are smarter than humans in the way that they don't attack things that are bigger than them. Okay, humans don't have that same level of intelligence for some reason, but some do. But that's the idea. Look bigger, try to be scary so you don't get attacked, right? This also helps with heat trapping too. If you have a lot of fur, like a wolf, or I don't know if it's a wolf or a coyote, but that traps heat in too. The air within the hair warms up and stays there, and so that helps you stay warm too. Okay, that one. So let's talk about these drugs. One of the great ways to learn the sympathetic and parasympathetic nervous systems is through learning about the drugs that interact with them, because there's a lot. So just chat about this one for a sec. Be ready with your answer to this, but then while you're waiting, go ahead and talk through these questions as well. All right. First question there. Every team need to see your vote. Okay. Yeah, so everybody's saying A. So it's an adrenergic agonist. Okay. These words are super helpful in understanding the sympathetic and parasympathetic nervous systems. So an agonist causes the same thing that nervous system would. Right? So if it's a sympathetic agonist, then whatever the sympathetic action is in that thing that you're studying, that's what the agonist does. It does the same thing. If it's a sympathetic antagonist, then it would do the opposite of that, right? It would do more what the parasympathetic nervous system does in that organ or in that tissue. Okay. Um, Adrenergic. What do those first five letters make you think of? Adrenaline, right? Which is connected to the adrenal gland, right? It's called the adrenal glands on top of our kidneys, right? So if it says adrenergic, which system are we talking about? Sympathetic every time. 100% of the time, adrenergic is sympathetic. Okay. And so if you see it's something to do with the adrenergic receptor, then it's either going to be blocking the sympathetic or activating the sympathetic, right? So if it's a um, adrenergic agonist, right, then it's doing the same thing that the sympathetic nervous system does. In this case, in the nose and blood vessels, in general, the sympathetic nervous system constricts blood vessels, right? So that's how it helps with our runny nose there. Okay. And then cholinergic, what does that one make you think of? Acetylcholine, right? And at the target tissue, that when we're talking about that second neuron, the postganglionic neuron, the one that communicates finally with the thing that we're the target tissue, um, it's always acetylcholine on the parasympathetic side, right? So if you see cholinergic, then you know that we're talking about the parasympathetic nervous system. Okay. Um, yeah. We already talked about this. Vasoconstriction, sympathetic, which system is a part of each receptor type. Again, cholinergic is parasympathetic, adrenergic, sympathetic. The last thing is, why doesn't it cause thick mucus production? Because that was one of the effects of the sympathetic nervous system. And this is where it gets into the specificity of what type of receptor each drug works for, right? So we have beta-1 receptors, beta-2, alpha-1, alpha-2, all that kind of stuff. We don't have to get into that for this class, but that's where it can kind of target a specific effect of the sympathetic nervous system with these types of drugs. Yeah, Ethan?
In general, if you're activating the sympathetic nervous system, does that automatically depress the parasympathetic and kind of inversely? So if it's something it's a cholinergic agonist,
Mhm.
would it be like, oh, like it's activating the parasympathetic and like the kind of blocking the sympathetic? Or no?
It doesn't necessarily block the sympathetic, but it has the opposite effect of the sympathetic. But yeah, it doesn't. Yeah, for sure. See, we always have both of them being activated at some level at all at any given time, right? So it's kind of like the level of which one that's kind of winning out in a certain area of the body. And so, yeah, that this drug will only do this one thing, right? It'll only bind to that receptor and have that effect, which is the opposite of of whatever in this case, it's the opposite of the parasympathetic nervous system, but it's not directly affecting the parasympathetic nervous system. Yeah. Other good question. Other questions on that? Yeah, Kendall. That stops your nose from running. Yeah, because we're not sending blood to the glands that produce the mucus, and so they can't produce as much mucus anymore. And yeah, and actually, a lot of a stuffy nose is just about blood vessels that are full of blood. So, like when you lay on your side, the and when you have a stuffed up nose and you lay on one side and this side opens up, how you guys have had that experience. It's actually due to a reflex in your armpit that causes your blood vessels on this side of your nose to open up. And yeah, and so it's kind of a weird thing. Most of the stuffiness we feel is actually just our nose filling with blood that keeps air, just limits the airflow, not so much about mucus. But obviously, there's some mucus in there too, but yeah. Yeah, it does. Yeah, yeah, typically it does. I mean, unless it's super, super stuffed up. But yeah, that's typically there's a weird little reflex by the pressure receptors in your armpit when you lay on it. It's a strange one. Yeah, I'm not sure exactly where it is, but you could try. Yeah, good question. Okay, all right. So more about drugs here. So in the eye, let's just walk through this one because we are running a bit short on time already. But yeah, so visiting the optometrist, he or she may put a drug in your eye called atropine. Okay, atropine is a drug that's going to dilate your pupil so they can see more of your retina. They can look at your blood vessels in your retina, kind of get a look at your vascular system in that way. This drug, yeah, acts on the synapse between the target tissue, oops, and the post. Here we are. Sorry, went to the wrong one. There we go. And the postganglionic neuron. Okay. And so this was one that we talked about, this atropine. This is a drug that acts on the muscarinic receptors. Okay, so the muscarinic ones are the ones, the cholinergic receptors that are at the end of the chain of neurons in the parasympathetic nervous system. So we have nicotinic first, and then we have muscarinic second. Okay, and then the other one here is this is related to cranial nerve 3, right? Because which of the two muscles in your eye is controlled by the parasympathetic nervous system and cranial nerve 3 with your pupil? You guys remember? Pupillary sphincter muscle, right? Not the dilator, but the sphincter muscle. That one's controlled by cranial nerve 3. Okay. And then the last one is that it's about parasympathetic activity. Optometrists also sometimes put phenylephrine in your eye, which is this drug we were talking about here. When they put phenylephrine in your eye, it also dilates, but that's because it's activating the sympathetic nervous system. It's activating that pupillary dilator muscle instead. So it's two different ways to do it, but yeah, either drug will cause dilation, but from different mechanisms. Yeah. Atropine? Yeah, it's a good question. I'm not sure. Yeah, I don't know. Yeah, check it out. I'll check it out too. Okay. Yeah, so let's go to the next one here. We'll just switch over to this one. Okay. My gosh, there's a bit. Okay, go ahead and work through this question. I had to get ready for that. Okay, now that your sympathetic nervous system's activated, answer this question. Okay, go for it. Answer this question. You got a minute. Still chasing you. It's not done yet. You gotta answer the question. Sorry, I'll turn it down a little bit. How to get the initial sympathetic activity? Sorry. All right, let's walk through this one together here. Okay, let's go ahead and walk through this one together. Sorry, keeps doing that. Okay. All right. I just wanted to activate your sympathetic nervous system, so hopefully I did it on a couple of you. It's fun to actually feel it, right? Hopefully you're not, whatever, we won't get into the details of that with this question, but it's fun to feel yourself sympathetically activated, right? And we're talking about it. So the things we don't want to happen would be, we don't need to pee right now, right? Some of you are probably thinking like, why do people pee sometimes when they freak out? Or why do people poop their pants sometimes when they freak out? How many people were asked that question in the group? Yeah, I heard you guys talking about just one. Okay. That has to do more with pressure. Okay. So if you got a really full bladder, you have a really full rectum, and all of a sudden you clamp everything down, that's pressure, right? Pressure is going to push that stuff out. Okay. That's not about your sympathetic and parasympathetic activity. In general, we're moving away from things like digestion and urination and all those things during sympathetic activity, right? So we are not going to contract our bladder because that would make us urinate, right? We're not going to relax our anal sphincter because that would allow us to defecate. And we're not going to contract the smooth muscle in our digestive tract, which would move food through, kind of continue that process of digestion. Okay. Next one, let's just walk through it together. Okay. Bear's still chasing you. I do have the audio on this one too, but I'm sparing you guys that. So this one is saying, which of the following things would you have happening? Okay. So thick mucus production, sympathetic activity means we want to save water, right? So all of our secretions decrease, right? Instead of secreting a bunch of water, it's going to be thick and not that much of it, right? And then we have a high heart rate, right? We need to circulate blood around our body. We dilate our airways. So it's kind of interesting, right? Sympathetic nervous system constricts our blood vessels, but dilates our airways, right? Because we need to get more air in, but we need to get high blood pressure, right? And so both those things are helpful. And then we've got, we can constrict our arteries, right? And then we dilate our pupils. That one, we just want to see as much as we can, right? We don't care to look at the details of that bear's face when it's chasing us. We just want to know it's there and where it's coming from, right? So we can get away from it, right? So, okay. Yeah, let's just finish with this one, then I'll give you the answers on the last one. Yeah, so this is kind of like a practice hybrid question-ish. Yeah, why don't I just do that? Why don't I just give you the answers here? So this one, you're just plugging in the cranial nerve number, so 7 and 9. This way you guys can study this. Let's see. In the nose, I increase cranial nerve 9. Oh yeah, and then the last one is parasympathetic. Okay. This one here, I think is a good thing for you to do on your own, really to kind of, it's just a way to study it, right? So you're just typing in whether it's sympathetic, parasympathetic, or somatic. Yeah, I'll just give you a hint to see if you got it right. So there's 11 on the sympathetic. Oops. On the parasympathetic, there's 9. And on the somatic, there's 5. Okay, but then you can kind of fill that in as a way to study. I'm happy to answer any questions you have on it after you do that. And then lastly, yeah, this is a kind of a practice hybrid question. I actually won't give you the answers on this one because I think this one would be good for you to study as well. But again, I'm happy to answer any questions you have. after you dive into it. Two things real quick. Number one, the first review session is tonight by the tutor, Olivia, and she's fantastic. So that's one thing. Number two, start trying to use that Notebook LM tool. I've created a bunch of like podcasts and things like that specifically for this class, specifically from the notes. So that's a super helpful one. And then lastly, sign up for office hours and come talk to me. I'm happy to help you with any material, answer your questions. So, all right. See you guys on Friday.
Thank you.
All right. Bye.
Not sure I was gonna go, but he said give it to all my teachers.
Okay,
and
cool. Yeah.
I'm not here. I got cleared to travel. If I'm
Yeah,
here, I did.
for sure. As
So,
long as you're communicating with me, just about, missing a lab or a test or something like that.
I don't think we'll miss any labs,
Okay,
but there's plenty Fridays.
plenty of Fridays, yeah, for sure.
But I'll be able to make it up.
So let's just plan that stuff ahead of time and find a time like you've done before. So,
Awesome.
all good.
Thank you.
Yep.
Thank you.
Bye. See you, man.
Any questions about the grounds?
About the what?
Gravel.
Sure.
When you look at the website for the grad school,
Okay.